Hi, my name is Jason Keogh. I'm the VP of Solutions at TeamViewer, and for those of you who have already made the decision that you want to do DEX, whatever DEX is, so DEX, Digital Employee Experience, you want to improve your end user's experience, you want to reduce your operating cost, have fewer things go wrong, improve your business's profits, you want to improve security. Great, you want to do DEX. Why should you do it with TeamViewer? So that's what this video is going to be looking to answer, and hopefully you find it informative. We used to talk a lot about automations, rules, instructions, things like that. We have thousands and thousands of them. You can use those 1863 objects to create new rules. They're components of rules. You can basically have infinity rules, and that's fantastic. There's lots out of the box, but that's getting less and less relevant over time. Technology ages. Some of the stuff that's there may be less valuable than it used to be. Technology is different from one organization to the next. So if there was only 1800, and there's far more than that, but let's say there was 1800, maybe only 300 of those are valid to you. If we added another 1,000, would that add any that are valid for your environment? Hard to know. And then ultimately there's AI. If you want something to do something, right? A script, a PowerShell script or a batch script in this case, or any kind of script to take an action to do something on an endpoint, you no longer need an expert. You don't need somebody who has the expertise to write that, the experience of having written that. You can turn to an LLM, Gemini, and the sort of image there on the right, or it could be ChatGPT, or pick your favorite poison, and essentially any tool then that can run a script can do anything that you can think of. So therefore, what a tool can do, or how many things a tool can do, is not a differentiator. So the differentiator becomes when a tool can do a thing, how a tool does a thing. And that's when architecture matters. And that's what we're going to talk about. So the only constant is change. Machines are changing state all the time. Maybe they're changing state from 19% CPU to 20% CPU. It's not a relevant change, right? Most changes, and it changes every millisecond, many times a millisecond potentially. Most events, something crashing, maybe that's relevant. Performance statistics, CPU, RAM, I/O, things like that. Responsiveness events, how long it takes to do something like read from the registry or open a file. Most of those events are unimportant. But some of them might lead to a negative impact, a security problem, digital friction, and a user having an issue and not being able to get what they want done, so a negative DEX experience. Cost and waste of time, waste of money. So ultimately, how do we look at the events that occur and identify the 0.00 something percent of them that are actually signal rather than noise? Ultimately, there's three key architectural choices that DEX tools must make in order to determine really how good they are, right? They're foundational choices and pivot points that change the when, where, and how things that can happen. And we can make a script to make anything happen, right, with AI. So these are the differentiators that are important. So is it polling or event-driven? Is the data centralized or distributed? And is there centralized intelligence or edge AI? In polling-based systems, events occur, performance, responsiveness, stability-based events, and after they've occurred, it assesses to see what's occurred. So they all occurred and we identified a foreground app has crashed. They all occurred and we identified that there was a security violation. Now this identification, this analysis can take place potentially on the device or off and against data that's in the cloud or on the device, and those are other factors. But polling-based systems look after the fact at what has happened and how quick is quick enough, how fast is fast enough, right? If an event is a user clicking on something for self-service, for example, how quick is quick enough? So I'm going to click here now, and that comes up. And if I'm a user, I expect a response to that. And if there's no response, I'm wondering what's happening. That was a 5-second response. Some of our competitors take minutes to recognize that an event has occurred. And obviously a user won't wait minutes. Some of our competitors will wait 15 seconds to assess what's happening. And 15 seconds, if that was 5 seconds, 15 seconds is a long time for a user to wait before they click the button again. Event-based logic means that as events occur, there's an immediate identification of that event, a security violation, an app crash, or whatever. If I click, I get an immediate response to say, give me admin access or whatever it is that I'm clicking for a self-service, for example. So in security, every second counts. If we have a delay, that's a problem. Users are not known for their patience. And if we're failing to fix things quickly, well, wasted minutes become wasted hours, and that's wasted money. I mean, really, the time that elapses between the event and the response opens what we call a window of vulnerability. So a bad actor, maybe it's an employee who's planning on leaving and they want to copy files onto a USB key. They circumvent the control, if you have such a control in place, by maybe getting local admin, and then they stick in they change the registry key, stick in a USB key. If they have seconds or minutes to do what they want there, they can copy a lot of files off. If it's a real bad actor, in terms of an attacker, they could do a lot. So there's an issue there in terms of security use cases. There's an issue in terms of users clicking and having to wait 15 seconds or 2 minutes or whatever for a response is not really acceptable. And there's a massive noise problem. If most of the events that occur are irrelevant, then we're actually spending cycles in terms of either cloud-based resources or on-prem, on-device resources, looking at events that are not relevant in order to determine, if they're relevant or not. And most of the time they won't be. Whereas event-driven responses are, real-time responses to events. They don't have a window of vulnerability by their nature. And there is no signal-to-noise ratio problem because there's only signal, there is no noise. The event is the signal and it's reacted to. Centralized or distributed data is the next question, right? So are you sending data to the cloud for central storage and then querying that, maybe with your polling-based system, to determine what's going on? If so, then only pre-stored data can be queried. No matter what your question is, if the data isn't already stored to answer it, you can't get an answer. Also, the larger your environment, the more devices, the more data, and the longer you want to look at data for or store data for, the more data. So this sort of system is inherently going to suffer from some kind of scale issue, whereas a distributed system keeps data on each device. So if you're looking for an answer, you're looking on each device at a very small data set, and if you can do that in parallel, you can look across all devices simultaneously. If each machine is looking at its own data set of the few thousand processes it has run in the month, it can analyze that in milliseconds typically, because it's only looking at a couple of megs. A couple of thousand rows is not a couple of billion rows. And if you have 50,000 machines and they all look at the same data on themselves and only on themselves simultaneously, and only those that actually match then send a response, well, you get ridiculously fast responses. That's what distributed data systems are famous for. So it scales horizontally. It doesn't matter how many devices you are. Each device is only scanning or looking at data from one device. Also, it's live data, not pre-stored. So therefore, you can query anything that the machine can tell you about. What is the value of this registry key right now? That's data that you have to have in your database if you want to query it. Or if you're doing a live query, you don't need to have it in your database. Just query the machine, you pull the data back. It's instantaneous. Another benefit, of course, is that you don't require network access in order to have distributed data work, whereas you do require network access for centralized data. Transferring data from when something happens on a device or periodically from the device up to the network, up to the cloud, takes time in and of itself. So this window of vulnerability concept is a bigger window of more vulnerability when you have centralized data than when you have distributed data. Then where are you doing your analysis? If you're sending the data up to the cloud, you're probably analyzing it there. If you're keeping the data local, you're probably analyzing it there. So some analysis engine needs to look at what's going on to identify the signal from the noise, and decide if some reaction maybe is required. So if you're doing centralized examination of that, then the data has to get from your device to the cloud before it can be assessed. Whereas you can use Edge AI, by which I just mean we have the intelligence of what we should do when an event occurs, the expert system, to use the AI term, on the device. So when the event occurs, the device can react to that event, ideally in real time. So the rules about how to react are distributed to the edge, and the machine does whatever it is it needs to do in that event. So obviously, again, here Edge AI is going to have the edge. With centralized analysis, again, you need the network to work. So if you want to determine something has happened and send a reaction back down, you're going to have network access. If you don't have network access, therefore, it's not suitable for security. It's not going to work, right? And in security use cases, you could disable your network in order to circumvent security controls. So centralized analysis is not good for anything related to security. Data transfer still takes time. The assessments are looking through that large centralized data set, so the window of vulnerability is larger again. Whereas in Edge AI, we're looking at a small set of data on the device, from the device, and the rule on how to react to an event, if it's an event-based system rather than a polling-based system, can trigger on the device as well in real time. If we're talking about architecture, we must have the architecture diagram. One of my colleagues said to me several years ago that the most connected tool will win, and I think they're right. It's really a matter of not just how do I get data from the endpoints to the platform, or how do I get actions to take effect on the endpoints when triggers occur, when events occur. It's also about how do I understand what has happened post-fact, and how do I get value or understand the value that I've gotten from the system? How do I interconnect it to things like my ITSM tooling, my SIM tools? How do I connect it out to BI and other visualization tools? So you'll see the word API a lot on the left-hand side here. Our own UIs in TeamViewer use the APIs to the platform. Everything is API first. We're also using Databricks now a lot for data storage in terms of offline data storage, so you can basically see data from devices that are not online right now. So it's not all distributed data. It's also aggregated, coalesced, and uploaded over periodically during the day, so you can look at and understand the last known state of devices that were online that are not currently online, and you can generate, use all the power of Databricks to generate reports and so on. So APIs are crucial, bi-directional APIs potentially. So if a SIM tool, if we're feeding data to a SIM tool and it sees a problem, that's a polling based system, by the way, so you might want to build that as a native automation, but people want to use their SIM tools. We send data to the SIM tool, they want the SIM tool to take an action, that SIM tool can take an action via API back to the DEX platform. So it's a bi-directional. Likewise with ServiceNow, we might see something occurring and log a ticket to say this occurred and we fixed it automatically. Equally, somebody using the ServiceNow tool as a level 1, level 2 person can interact with devices live through the DEX platform through APIs and execute instructions, get immediate feedback and results, and also obviously take remote control with TeamViewer and dive directly in and actually have AI analyze that session and all sorts of really, really cool stuff. So hopefully this discussion of architecture has helped you understand why TeamViewer is absolutely the best choice for your DEX requirements. But genuinely, there's a number of unique differentiators enabled by the architectural decisions that we made many, many years ago when we started building the DEX platform. So yeah, reach out to find out more. Thank you, and until next time.